everybody. Now we have 18 students. We have 10 more students. They're still not here. I think they are a bit tired or doing something else. You can always refer to my recorded lecture. Okay, just to recap where are we doing last time. Let me show you where were we last time. So we have covered for the last 3 meetings introduction to control, and then mathematical modeling of engineering system. For 2 weeks we have covered about mathematical modeling of engineering system for electrical, for mechanical, for electrical, and also for MEMS and mechanical electrical system. So for today I'm going to cover chapter 2, which is system model representation. Okay, system model representation. If we refer to our syllabus, what we have done so far. Okay, we have covered okay, we have covered Laplace concept review. Okay, review Laplace, element control system, open loop and closed loop system, different type of controller. Okay, and then you have we went through the introduction to simulation tool to control system design, which is your level. And then in our last 2 meetings, we have covered modeling of engineering system. We have take a look of a mechanical system, electrical system, electromechanical and electronics, and then this one we didn't cover. Okay, so for today I'm going to go through with you the next topic, which is the topic related to system model representation. So what I'm going to cover in this chapter is basically going to look at the transfer function. Okay, transfer function, and then we look at what state space representation, and then we will have a block diagram. Okay, block diagram, and last but not least is a signal flow diagram. Okay, signal flow diagram. So this is what we're going to do for this week. Okay. Now I'm going to proceed to our today's lecture. Okay. 21 students now. Okay. All of you have this note already, right? I have sent to you in your WhatsApp group and also in our Google Classroom.
Yes, sir.
Okay. So what we did is we start with chapter 1 and then chapter 3, and then we come back to chapter 2, which is system model representation. Okay, now we discuss about transfer function. Okay, transfer function. So transfer function, what is transfer function? So It is basically it is the way for us to show input and output relation, okay, between variable. Okay, so we have here so we have here transfer function um, from Laplace transform. Okay, my internet just okay. Yes, I'll get back to normal. Can you hear me?
Yes,
All right. Let me share again. So what we did just now is to share you the system model representation. System model representation. So basically for chapter 2 is basically we want to present output and input. And we have assumed that the energy collision are zero. So what we did, we divide or get the ratio. Okay. For example, output divided by input ys divided by us. Okay. So it's going to be as the following. We have to write in this form. We have b dot and then s to the power of n. Okay. This is in general form. In general form. Then we have another constant, and then s to the power of m plus 1. Okay, and then dot 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 until towards the end we have only the m. Okay. Same thing for the lower part, okay, which is us. Going to have a s to the power of n, and then plus a dot, and then s to the power of n minus 1, and plus dot dot dot, and then you're going to have a n, okay, and then times s plus, and towards the end you have a n. So you find the ratio of these two, okay, and then this one, this is 2, so y is y1 divided by 2. Okay, so this is equation 2.1. Okay. So in other words, what I'm going to, in a nutshell, what is transfer function is basically is defined as the ratio of the output and the input. Okay. And the input, that is how do we define transfer function. Okay. Okay, look at here. We have this example. This example is a closed loop control system. Okay, closed loop control system. So we have this block diagram. Okay, this block diagram. So what we're going to do, we want to find the transfer function of the above block diagram. Okay, so based on our definition just now, okay, transfer function ys divided by us. Okay, in this case we have gs or gs divided by the way we write 1 plus gs hs. Okay, so the way we write is going to be given as the following. Okay, so gs divided by 1 plus gs times hs. Okay, so this transfer function we can also write in this general form. Okay, in general form. So it's going to be in this general form. You can write k, the summation, okay, of a, okay, s to the power of k, okay. So k from 0 to m, okay. Then we divide by s, the summation, okay, summation of a, s to the power of k. Okay. You have to memorize all of this because all of this in the text. So it's like a cookbook. The main thing is you need to know where to find this and how to use. Okay, let us see how they define how all these equations will be defined. Question 2.3. This is what we call the classification. Okay, for the classification of the transfer function. So it is based on number one, based on the order. Okay, so in this case, the highest power of s. Okay, the order, the highest power of s. Okay, in denominator n. Okay, so highest power of s. So one highest power of s in denominator n. Okay, and then number two is type. Okay, the power factor s. Okay, in denominator l. Okay, and then rank. Okay, rank, the difference between the highest power of s denominator, okay, denominator and numerator. So denominator ni maksudnya apa? What is denominator? Kan dia ada beza, dia ada numerator, itu denominator. Istilah lah kan, atas dengan bawah lah kan. So the difference between the highest power of S denominator and the highest power of S in the numerator. Okay, so M. So to calculate a rank, maknanya we have to minus lah, N minus M. Okay, and this value should be positive. Okay, should be zero, should be more or equal to 1. Okay, more or equal. This is how do we define. So you need to familiar lah with the word order, okay, order, then type, okay, and then rank or rank. Main game dulu ranking nombor berapa? Kalau main badminton ranking nombor berapa? So to calculate rank is this one. Okay. Okay, I have mentioned about tadi transfer function. This is dia punya basic equation. And then kalau for closed loop system, how do we apply transfer function to show the closed loop system? Okay, example lah. So the detail will go. We will do it. We will explain later. In detail in other chapter. Okay. And then this is the way to write in general form. Okay. All right. 2.1 we talk about characteristic equation. Okay. I think you are familiar with this term. Okay, because you have learned in linear algebra. Also, you've been exposed to this. Okay. So just now you have equation 2.1. Recall, this is equation 2.1. Equation 2.1 is from here. Equation 2.1. Okay. You want to look into characteristic equation, okay, of a linear system. Okay, so sometimes it is referred as linear time invariant. Okay, linear time invariant. Okay, this is a short form of this. Called linear time invariant or linear system. So characteristic equation, basically we define it as an equation obtained by setting the denominator polynomial of the transfer function to 0. Okay, so denominator of polynomial. Okay, so which one? Denominator. Maknanya tadi atas numerator, bawah is denominator. So the value that of the denominator we set this one equal to 0. So this is what we call characteristic equation. Okay, characteristic equation. So we set this one lah, the denominator of equation 2.1. Okay, of equation 2.1 we set it, okay, to 0. Okay, or in other word, tadi kan kalau yang tengok yang closed loop system tu contoh tadi, the one that I have shown to you kan, yang contoh closed loop yang ni lah, this one which is the denominator for transfer function of the closed loop. So this one we set it to be 0, right? So it's going to be in this form. Okay, 2.4, 2.5. So characteristic equation, numerator equal to 0. Okay. So what is the function of it? You're going to know or to use it later. So we're going to use characteristic equation in order for us to describe the behavior of the system. Okay. Behavior dia. Kemudian dia punya root of the characteristic. Because this one when you set equal 0, you're going to get dia punya root dia lah, berapa? Contoh plus or minus kan. So you're going to get a root plus or minus. So that one will give you the information about the system stability. Okay. That's why we as engineer, we don't look at look number simply a number. Because based on this equation, we can know whether the system, the behavior of the system, and then we can know whether the system is stable or not. Okay. Okay. We have done in terms of the introduction. Now we want to go through step by step what will be like a cookbook or the procedure to find transfer function. Okay. What will be the step? Okay. Steps and procedure to find transfer function. Okay. We start with the first one. This is the step. Okay. We go through the step and then we'll do example. Are you follow? Do you follow me?
Yes, sir.
Okay. First, we write a set of, let me make it big. What is here? What is this? Rotate plus. Upside down. I want to enlarge. Alright. Start with the first one. To write a set of linearly independent integral differential equation. Okay. So start by writing this one. This is dependent integral. So we have the dy dt, d square y dt, dt square, d cube y dt cube plus, then whatever lah, a dot dn minus 1 y divided. This is what we call this in general form. In general form. Sampai last kali, you're going to get an times y lah, to the power of 1. Okay. Same thing for this one. Yang this is right, left hand. Left hand, this is right. Okay. Kiri yang kanan lah. Okay. So we can write in this form. This is what we call a linearly independent integral differential equation. Okay. 2 points. After that, after you are given this, what you need to do is you need to convert the equation using Laplace transform. Okay. You assume that initial condition equal to 0. Okay. So you convert all of this equation in frequency domain. Okay. Both Laplace. Okay. Both you apply Laplace. Okay. Both sides. Put in parentheses here. Okay. Left hand. This is what we call bracket lah. Orang kita sebut bracket lah. Okay. Kalau mereka sebut at least parenthesis lah. Okay. Okay. Bracket or parenthesis. Okay. Left, right hand, left hand, both you take Laplace transform. Okay. And then what you need to do, you solve the resulting set of n linearly independent algebraic equation, okay, in n independent variable of Laplace of the output in term of Laplace transform of the input. Faham tak? Maknanya balik pada tadi lah, transfer function output divided by input lah, right? So For this case, what you have just now, this one, okay, this is y, okay, and then this u, okay, output divided by input. And then you're going to find the relation between Laplace of the output and input. So you eliminate anything that you can cancel out, and then you're going to get resultant equation in transfer function as the following. So maknanya you cross multiply here. So this one goes down, and then this one will be here. So y over s, you're going to get b dot 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 divided by s n. Okay, this is the resultant equation in transfer function. Okay, now we want to see whether we have a good example to make this concept clear. Okay, we have one. Okay, work example one. So now we have differential equation. In this case, y as in output, okay, and us is in input, right? Okay, output input. So you need to find the transfer function. So you are given here differential equation here. Okay, 210. You're given this form. So you have 12 t square y dt square plus 12 dy dt plus 32y, okay, equal to 7 du dt. Okay, this is an output, and then this input. So du dt plus 32 ut. Okay, so by follow the cookbook of steps that we have done just now. Okay, so we're going to have your put together in parentheses here. Okay, both sides, left and right. Okay, in this order, put Laplace for both, and then it's going to be in the Laplace transform. Okay, so square here, so s square plus this is u, is u dy dt as s, and then 32y, okay, constant, and then you introduce ys output. Then here d 7 du dt 7s plus constant here, and then you multiply by it. Now you take the ratio of the equation to 12. So you're going to get 7s plus 32 divided by s squared plus 12s plus 32. So it's clearer, right? The concept, and then we do examples. I think it's clearer, right? The way we apply
Yes.
with this work example. Okay. All right. Okay. Apa fadilat or the advantages of transfer function? Why we have to put it in that form, which is in the transfer function form. Okay. Of course, there are many benefits or advantages of transfer function. Right. One of it is because when we mentioned about transfer function, we want to, it is a tool to analyze a control system. Okay, so it will give us the plus point of using it. Number one is it will give us the overall connection between the system. Okay, in terms of a mathematical relationship. Okay, therefore we can analyze individual component of the system. Okay, when you have the overall connection between the system, okay, in terms of mathematical relationship. Okay, so we can go into a single part or single component of the system to be analyzed. Okay. Number two is we are going to know or to get some stability analysis. Okay, we can get the information whether the system is stable or not. Okay, how? From the characteristic equation that I have defined earlier. Okay, maknanya the denominator tu we set it equal to 0. Okay, when you set equal to 0, we can get the information. Okay? Get the information about the poles, about zeros, and etc. Number three is by using a Laplace transform approach. Okay, it will facilitate the conversion of the integral of differential time domain. Kan kalau sebelum tu tengok the integral differential time domain tu dia will not give us much information, but when you transform it to Laplace transform, so it will give you a simple algebraic equation. Okay, alright. So the rest is you can also express transfer function in complex variable. Okay, complex number, complex variable. Okay, which is not a function of a real variable. Okay, of any other variable, which is we can use as an independent variable. And then another thing is we can also get the property of the unique equation with system. Okay, which is depends on the value of the parameter or the constant of the system. So this is independent of the input. So these are the advantages of transfer function. Okay, we take a 5-minute break and then we continue to the next section, which is space representation. I'm going to go through the general concept of it, and then we are going to do example. Okay.